This is an irrigation control valve box. Inside we have the irrigation valves that control your sprinkler system. So as we can see, there's 3 valves in here, and they've separated them enough so that if they ever need to get into the hole and do some maintenance on one of these valves by removing it, they have enough space between the valves to not affect the others. Also, they've got wire connectors on these connections that are watertight. These have grease inside them to keep them from leaking so they won't corrode. And then they've got gravel in the bottom of the hole so that if this ever gets water in it, it won't silt over the top of the valves. Another thing you'll notice is that this device right here is for the drip system. This is a filter to keep the water clean and not clog the drippers, and down below that is a pressure reducer. The other component that's important to know on these valves is this on-off switch. If I turn this way, this will open up that sprinkler system manually. If I need to lower the volume of water coming through the system, this valve right here, this handle right here does that for me. And that's our valve box. This is an example of a manifold pit before they've actually connected the valves and the laterals to the valves. So I wanted to show you some of the components that make that up. This is a valve manifold. The contractor will put this together before he actually digs the pit. One of the key components here is that they've left enough room between this T and this male adapter so that if there's ever a problem with this valve, they can cut this pipe and reconnect a new one. So that's a critical element when you're putting together a manifold. They've also done that between these T's, so again, if there's ever a problem, they can sever that one and put a new one on and replace any problems with the valves. Good long-term planning. Over here, you'll see that this 1-inch pipe coming in is the main line. So that's the supply line, and the 1-inch main line is a Schedule 40 pipe. And what that means is it has a much thicker wall because that pipe is always under pressure. Depending on your area and what your water pressure is, sometimes as much as 100 and 150 psi. So that line is a thicker line and it's more durable. Our other lines coming in are they're either Class 200 or 1120, and they're a thinner wall pipe, and the reason is because they're not under as much pressure. They only have water and pressure in them when the sprinkler is running, and because water is running out the other end, they don't build up as much pressure in the line, and as a result, we don't need as thick of a pipe. Some people like to use Schedule 40 for their entire system. There's nothing wrong with that. One just needs to design for that because the thicker wall makes a smaller interior diameter, so you need larger pipe for the same amount of water. You also see that the depth on these pipes, the main line, we like to put it at the bottom of the trench, 12 to 15 inches deep. And above that are our lateral lines, and they're anywhere from 12 to 9 inches deep, depending on what your circumstances have in store. This also is the control wire. This has multiple strands inside of it along with a ground wire, and this will go back to the controller so that the controller connects to these valves and tells them when to shut on and off. I'm going to go over the lateral pipes that connect to our pop-ups. Pop-ups come in a few different sizes, typically 4-inch, 6-inch, and 12-inch, depending on what the planting is, how high you need to get up to go over the tops of your plants. 4-inch is usually used for lawn areas, 6-inch for ground covers, and 12-inch if you have a higher ground cover or some shrub areas. Right here you see an example of a 6-inch pop-up. One of the things to note is that there is a swing joint on the bottom here. The reason we use a swing joint is so that if this head has to be adjusted in height, it can be, but also if anything ever happens to this, there's any impact on that head, it has some flexibility, and that way it won't snap the pipe. Sometimes people just use a T that goes right on top of the pipe, and any impact can actually crack the pipe, and that makes it a lot harder to fix as well. So we use swing joints on all of our heads. Also, one of the things I want to make a point of is these heads have a side inlet and they have a bottom inlet. We always use the bottom inlet. If you have lower pressure for your water, The side inlet usually doesn't work to push the head all the way up out of the ground. So if you see that there's a problem with the head lifting, probably what's going on is either your pressure is too low and it was over designed, or there's not enough pressure and it was the side inlet was used. This is a 12-inch pop-up, and as you can see, it's much taller. Typically for these, you would dig a hole right for the head itself. The pipe would come in at a higher elevation, and then this swing joint allows you to pivot the head right down into the trench. So that's the difference between a 6-inch and a 12-inch pop-up. This is a quick example of a backflow preventer. This one's called a double check. And every city and county has different regulations, but the purpose of a backflow device is to make sure that the water from your sprinkler system does not backflow or siphon back into your potable water system for your inside of your home. This particular device, if you look at the specifications that you have with your package, you'll notice that there's a detail of this. And a couple of the key components of this are the union. This allows for servicing of the device to make it very easy to take on and off. Here you have a ball valve on each side of the device. What I like about this is it enables me to turn off the entire sprinkler system with the turn of this one handle, and in that way I don't have to affect my water system inside my home. And then, as you can see, we've hidden this behind planting, which I recommend just for cosmetic reasons. What you see here is a combination of brass and copper fittings. This could also be Schedule 80 PVC. What you don't see is white PVC because that will be damaged by the sun, so we don't use that for any applications above ground. The other benefit of this device is that it avoids the need for anti-siphon valves for the entire system, and then you can put your valves underground where they're not visible and they're not subject to frost and things like that. So it also enables you to not worry about what the grade is for your property. When you're using an anti-siphon valve, all of your valves have to be higher than the area that they service. So potentially, if you have a sloped area, you have to put your valves way up in high areas to deal with that potential issue. This is an anti-siphon irrigation valve. A couple of things I want to point out about it. When installing these, I encourage you to use this type of pipe. This is called Schedule 80 PVC, and its characteristic is the gray color. That's the easiest way to know you're using Schedule 80. A lot of people use white PVC, and they put a male adapter on here and thread it right into the valve. I encourage you not to do that. The white PVC is not supposed to be used above ground, so when you do that, it becomes brittle, and over time it's very easy to crack that pipe. So use Schedule 80 when doing this type of connection. The other thing is that the way that this prevents water from siphoning from the irrigation system back into your home potable water is through this right here. This is the anti-siphon device, and this allows air into the line as the valve is shutting off. When the air is allowed into the valve, this can fully shut down, and in that way water does not siphon back into your home potable water system. Also, the final component is that installing these valves, one needs to install the valve 6 inches or more higher than the head that this is servicing. So if this is out here spraying water to a pop-up that's at this level, this valve needs to be 6 inches or more higher than the head itself. So if you have high pop-ups or high risers, you need to make sure that your valve stays 6 inches higher than the riser or the pop-up that it's servicing.